tree city, there are n tourist attractions uniquely labeled 1 to n. The attractions are connected by a set of n minus 1 bidirectional roads in such a way that the tourist can get from any attraction to any other using the some path of roads, using some path of the roads. Okay, so that means it is a tree. So you are the member of the tree running a committee. After much research into the tourism committee, interesting fact about the tourist, the love number theory. A tourist who visits an attraction with level X will then visit another attraction with level Y if Y greater than X and Y is a multiple of X. Okay. Moreover, if the two attractions are not directly connected by a road, the tourist will necessarily visit all the attractions of the path connecting X and Y even if they aren't multiple of X. The number of attractions visited include X and Y themselves. Call this the length of a path. Consider the city map. This here all the paths the tourist might take with the length for each from one where it can go. It wants to visit all the nodes which are divisible by 1, right? So 1 to 2 4. So what is the length? 1 2 3 from 1 to 2. What is this? The length is the length of a path, the number of attractions visited including X and Y themselves. But if the two attractions are not directly connected by a road, the tourist will necessarily visit all the attractions on the path connecting X and Y. So if X and Y are not directly connected, so it will go from X to Y using some of the paths because it is a tree. Any two of the nodes will always be connected. So even if they aren't multiple of X, the number of attractions visited including X and Y themselves. Okay, so call this the length of a path. So length of a path 1 2 3. No, it is the number. Okay, node number. Is it so? 4. So 1 2 3. 1 2 3 1. Okay, it is visiting 3 nodes, so it is 3. So from 1 to 4, if it wants to, it should be 2. Okay, 1 to 5, it should be 2. 1 to 6, 1 2 3. I think I got that. So okay, this is the length of the path. To take advantage of this phenomena of the tourist behavior, the committee would like to determine the number of attractions on the path from an attraction X to attraction Y such that Y is a multiple of X. You are to compute the sum of the length of all the such paths. Okay, so for any given pair X and Y, if X divides Y, then we have to go from X to Y and see how many nodes are lying in that path. So for all the paths we have to find the sum. Is it so? Yep. Okay, 200,000 n, and it is a tree, so n, the single test case. The first line of the input will consider an integer n. Each of the following n minus 1 names contain a pair. Okay, n minus 1 edges are there. You have to get that value. Okay, so traveling between two paths, between two nodes, so the number of edges we can get. So let's see. So if we want to go from this node to this node, okay, so if we look at any two nodes, so let's say from here to here, what is the shortest path? So that should come through LCA only, right? So we need to route the tree at some node. Let's say we route the tree at this node. Okay, so this is my route. Now what should happen? Yes. So between two nodes x and y, this one. So between two nodes x and y, so x, if y mod x is equal to 0, then only count this 1 2 3 4. It contributes 4. Can we say how many times a node will contribute? Okay, but how will you decide? So if I try to find the contribution of this node, I don't know. So it will be it's so in the rooted tree. This will be the root. This will be the first child. This will be the second child. So this has the parent. So something in the above side, something in the subtree. Okay, so anything. So one is in this subtree, right? So all the nodes which are here and all the nodes which are above this node. Okay, so if I pick any two nodes here, so there will be a path passing through this. If I pick any two child of this node, so there will be a path. But how to say that this child will have? Okay, so if we find, okay, I think between two nodes this should not work. So what if I want to generate all those nodes, for all those x, all the y which are divisible by x, go to all those nodes, okay, and find the length between them. So 1 2 3. So whatever the length is plus 1 will be the contribution of the it is easier x and y. So how to find the, okay, I think I can find the LCA in log n time. Okay, and for every pair of node it will take n square. How to decrease this thing? So what if I want to, okay, so x, for every x I will iterate over every y and check y mod x is equal to 0, then only consider that pair. But what if for a given x, okay, if I try to go to 2x, 3x, 4x, 5x, that means all these values, right? So if I try to go to all these values, I think log sieve, prime sieve, same algorithm. So go to all the y is equal to 2x and y less than equal to n and y plus is equal to x. So for every x, for all x, y's will be this one. Okay, so that means it will be n log n, and log n for the LCA. So these many pairs, and this will be the LCA. Will it pass? I think yep, it should work. 20. Okay, I got this. So for every x and y, so such that y is a multiple of x, find their LCA. Okay, LCA, after finding the LCA, find the length of the path. So from this node to this node, what is from this node? So from this node to this node, whatever the length is, 1 2 3, so plus 1 will be the number of nodes visited. So that will contribute 4. I think let's code this and see. Okay, so first line contains n and minus 1 is okay, let's define the adjacency log and int n and nodes, and for each of the edges we can read two values x and y. Can push adjacency of x, push back y, and adjacency of y dot push back x. After this we have the adjacency, then go to all the nodes. So x is these nodes, x less than equal to n, go to each node and go to for all the y's which will start. Okay, so 2 times x, y less than equal to n, y plus is equal to x. So we have these two nodes. Let's find the LCA. Let's find the LCA between x and y. Okay, let's say G is the LCA. So length between x and y. Okay, I think we can say answer plus, what is answer? The answer is the length. Let's write length directly here. It will calculate LCA. So path length between x and y, okay, plus 1. I think let's call the length, let's define length as it is, what is defined, and length will add plus 1, then return the answer. Okay, so we have read the n in edges, n minus 1 edges, created the adjacency, and go to all the x's and go to all the y which are multiple of x's, and find the length between x and y and return the answer. This answer should not overflow, because there will be n minus 1 edge. Okay, so between every node, so we have a I think it will overflow. So 11. Before this we will have to call the DFS to calculate our else sparse table. On node 1, parent is minus 1, it will create the sparse table, and then length function will call the LCA function. Okay, let's write the DFS. What is the parent? So we can say the direct parent of u is the parent. Okay. I think we will have to create a vector or int parent of, so log of, so nth parent of, so 2 raised to jth parent of I. You can say direct parent of u is the parent only, and let's go and calculate for all the j is equal to log, so 2, we can say parent of u, 2 raised to jth parent of u is take a jump of 2 raised to j minus 1 from u, and from there again take a jump of j minus 1. Okay, it will calculate this. But what if parent is minus 1? So let's add this value. If parent, okay, parent of u I can only calculate the jth parent if and only if j minus 1th parent is not equal to minus 1. It should not be minus 1, and j should be, otherwise everything has minus 1 minus 1. Or let's make it 0. Okay, this is not required then. Can safely go. The direct parent of u is 0 only. Okay, go to all the nodes, go to all the values of j till log j, and take a jump. Okay, it will create the sparse table. So after this I will know all the parts of two parents of u. Now let's calculate the same for the children. Find v over adjacency of u. If v is parent, we can say continue. Otherwise, you can call DFS on v with the parent as u. Okay, then it will go to v, and direct parent of v will become u, and calculate everything for v. Right, for that child it will keep on calculating. So we will have this sparse table created after this. Now let's write the length function. Okay, what is the length between two nodes x and y? Okay, you can say length is nothing but okay, depth. We have to calculate depth also, right? That will be required for LCA, depth of each node. Okay, depth of u is 0 only. Here we can say, so depth of v is nothing but 1 plus depth of u, and depth of u is 0. Okay, depth of u is 0, so it will become 1, its child will become 2. Okay, we have got the depth. You can return depth of length between 2. So depth of y minus 2 times depth of the LCA of x and y and length. So number of nodes is 1 plus 1. Is it true? Length of x, calculate length of x, y minus 2 times, remove that LCA node, plus 1. Because we have to count the node number of nodes, not the path length, okay, not the edge length, number of edges. Okay, so let's write the LCA function between u and v. What is the LCA? So if the depth, let's generalize it, if depth of u is less than depth of v, that means we can swap u and v. After this, u is at higher depth. Let's move. So what is the difference? You can say depth of u minus depth of v. This is the gap. Let's jump. J is equal to log. Why log is not working? Log is 25 now. So j is equal to log equal to 0, j minus. So we can say the depth of u minus depth of v equal to j is equal to log j minus. Okay, let's take a jump of j steps, 2 raised to j steps, if and only if this bit is set. If this bit is set, we can take a jump of j steps. Okay, that means my u will become the 2 raised to jth power. raised to jth parent of u. Okay, after this, what if u and v are equal, we can return u is the direct parent. Otherwise, let's take the jumps. Okay, if these two parents are not equal, then only take jump, right? So if the jth parent of u is not equal to jth parent of v, these two are not equal, then u is PR of u raised to j and v is parent of v raised to j of j. Then finally we can say who is the parent, who is the LCA. It is nothing but direct parent of u is the LCA. Okay, after this I think it should work. Let's see. Read the input. Okay, create the graph. DFS, call the DFS. DFS will calculate the direct parent of u. Okay, go to all the powers of 2 and parent 2 raised to jth parent of u is nothing but is to j minus 1th parent, and for that node j minus 1th. Okay, then go to all the child, calculate their depths, and okay, LCA is computed. Now length function is called depth of x plus depth of y minus 2 times depth of LCA of x and y plus 1. What is LCA of u and v? If u is at higher than v, then okay, swap so that u is lower than v. What is the gap? Gap is diff. Let's move up for this amount. How can we move? So take the jump in the binary format. If the bit is set, then u is equal to parent of uj. Okay, if the bit is set, then only take the jump. Okay, go from higher powers of j, doesn't matter. If u is equal to v, return u, fine, then take the jump, do a binary search, right? So can I take this much jump? Yeah, yep, you can. So if and only if I'm not crossing the LCA, okay, that means these two are not equal, then only take the jump. Keep on jumping until this condition is met. These two are equal. For j equal to 0, it will be equal. So PR. Okay, I think it should work. Let's try. My sublime has to be fixed. Okay, same error. Let's try in submitting it. Where to submit? I've already solved it 3 or 4 years back. Anyway. Okay, runtime error. Great. Why? Is my input wrong? Two into 10 raised to 5. It's fine. X is 2 into 10 raised to 5. What is the log value? Okay, next and log. Go to till log. Why it is runtime? Runtime error. DFS is also fine. Okay, direct parent of u is parent only. Go to all of them. Calculate this value. Okay. Student depth of LCA of x and y plus 1. And go to all the nodes. Why it is not working? Adjacency is also fine. Is it due to this line or what? Let's see. Maybe some problem with the compiler. Let's try int. Maybe it will fail. Whatever. Okay, runtime error. Why runtime error? I'm reading n. Okay, and reading n minus 1 lines also. X and y. X push back y push back x. Calling the DFS. x1 to n. 2x equal to y plus equal to x. Length of x and y. Depth of u is less than depth of v. Swap u and v. Find the diff. Okay, go up from u. If v and u are equal, return u. Go to parents are not equal. Keep on moving. Finally, this one. Depth is also fine. Why it is wrong? At least runtime error should go now. Let's see. What could be wrong? Okay. Is my log value less? I do it 30. But I don't think that is the problem. Because first test case only. What? Due to performance problem solving is currently being updated slowly. What's the issue? Okay, let's see. Diff with this solution. Okay, we need to return answer. We don't need to return the answer. We need to see out the answer. What the fuck I'm doing? Okay. Return 0. Okay. Okay, at least worked something. Fine. It is wrong answer. Why? Let's remove all this. Let's make it 25. Okay. Let's make it long. Now. length should also be, length between two nodes will always be integer only. Okay. Acha. What the? Okay, working. Fine. Fine. Yep. Worked. Nice question.